Hello everyone, today we are going to discuss about the vector clocks in distributed system. So first of all we will see the concept of vector clocks. So whenever you have to find the dependence between the set of events, then we are considering the concept of vector clocks as it is used to track the causality between the events. So the causality is nothing but the dependence between the events, and we are considering the ordering of events among that set of multiple nodes or processes. So the concept of vector clocks is used to track the causality and sequence of events across the various nodes or set of processes. For this purpose, each process in the system maintains a vector of logical clocks with each element in the vector representing the state of that process clock. When event occurs, these clocks are incremented by 1 and vectors are exchanged and updated during communication between the set of processes. The main idea behind the use of vector clock is they will allow the system to find out whether any one event has happened before another, or whether the two events are executing parallelly, or whether they are causally related, means whether they are dependent on each other or not. So this is particularly useful in the distributed systems where the global clock is not available and processes need to coordinate actions without the central control. Now we will see the various use cases of vector clocks. First of all, it is mainly used for the conflict resolution in the distributed databases. For instance, if we are considering the Amazon DynamoDB or Cassandra, here the vector clocks are used to resolve the conflicts when different replicas of data are updated independently. Again, it is used for the version control in collaborative editing. Various editing tools, Google Docs, will make use of this vector clocks where multiple users can edit the same document simultaneously. Also, it is used for detecting the causality in event-driven systems. In event-driven systems, where the sequence is very important, in that case, vector clocks are used. Instance can be in distributed logging or monitoring system. Similarly, vector clocks are used in the distributed debugging and monitoring. Here, its purpose is for understanding the order of operations across different nodes. Again, it is used for ensuring the consistency in distributed file systems like GFS or HDFS, where multiple clients may access and modify the files parallelly. Also, it is used in the concurrency control in distributed transactions. Here, it will make sure that there is the correct sequence across different nodes. Also, vector clocks are used for the coordination of distributed systems. So, in systems that require the coordination across different components like microservices architectures, therein vector clocks are used. Now we will discuss about the advantages of vector clocks. As we have discussed earlier, for the finding of causality or dependence between the events, vector clock is used. So the first benefit will be the causality tracking. It will allow the distributed system to accurately track the causal relationship between the events. Again, as discussed earlier, it is used for the conflict resolution. It will provide the efficient way to detect and resolve the conflicts that will happen due to the parallel updates or operations in the distributed system. Also, it is used for efficient event ordering, and it will not require the central coordinator for the same. Again, it is efficient during the fault tolerance. It will handle the network partitions or network failure efficiently. It will consider handling the scalability and accuracy effectively. It will not require the global synchronization or coordination for the same. Now we will see the various loopholes of vector clocks. When we are considering a system with huge number of nodes, the size of vector clock will increase linearly with the number of nodes, and it will lead to the scalability issues, having the overhead in the terms of memory usage and communication cost. Also, for complexity in implementation, where nodes frequently join and leave, or where network partitions are common. Also, vector clocks are having the limitation in partial ordering, where they will determine the causal relationship between few events but not all, and this will lead to the ambiguity in determining the exact order of events. Also, it is having the overhead when you are doing the communication. Whenever any message is sent between the nodes, the inclusion of vector clock is must, which will increase the size of that message, and it will affect the bandwidth constraint, or it will consider the low latency. Also, it is limited by the network dynamics. Vector clock will always consider the stable set of nodes. When we are considering highly dynamic systems where the nodes are constantly joining and leaving, managing the vector clocks will become a challenge and will lead to the inconsistencies. Now we will discuss the vector clock algorithm. First of all the clocks are set to 0. Then each time, whenever there is the occurrence of internal event in any process, then the value of that process logical clock in the vector is incremented by 1. Also, each time the process will send a message, the value of process logical clock in the vector will be incremented by 1. Each time, whenever the process receives a message, the value of the process logical clock in the vector is incremented by 1. Also, whenever any element is updated, then it will take the maximum value in its own vector clock and value in the vector in the received message for each and every element. So we can summarize that the value of vector for each process in the logical clock will increment by 1 whenever there is the occurrence of internal event, or whenever the message is sent, whenever the message is received, or whenever there is the updation amongst the values or the elements. We will see the instance for the working of vector clock algorithm. We are considering here the process P, and it is having the vector of size n for each of the processes. Here you can see there are three set of processes P1, P2, P3 having their own vector clock. Here initially for P1 it is having the vector clock with the values 1 0 0. It is considered for first event occurring at the process P1. Then after occurring the second event, the value of that first event is incremented by 1. As we have discussed earlier, whenever the event occurs, the value is incremented by 1. So here the value becomes twice. And then this particular event is dependent or having the causality with the P2 event. So the P2 is having its first event with the value 0 1 0. Happening of the middle event is done for this process. Then this particular P1 event is given as input for this particular second event of P2. So naturally it will consider the value 2 passed by the P1 as the first input, and the value of the middle event is incremented by 1. As we have discussed already, whenever there is the occurrence of second event, the value is incremented by 1. Likewise, whenever there is the occurrence of third event, again the value is incremented by 1 for the middle event. So it is 2 3 1, and this 1 is considered from the P3 event. So again here the event from P3 is transferred to the P2. So we can say that whenever the event is transferred from any particular process to the another process, its value is considered as it is. Here 1 is passed, so it is considered as it is. Here you can see 2 was passed, it is considered as it is as the first value for the P2 event. Similarly here for P1, whenever there is third event, the value of 2 is incremented by 1 here. Again it is incremented by 1 for the fourth event, and this P2 is transferred as the input for this particular fourth event. So the value 4 here is considered as it is for this particular fourth event, along with the value 1. So 4 1, these two values are considered from P2 to P1. Again the fifth event is considering the value of this 4 incremented by 1, as it is the another second event happening after this. So you can see whenever there is the occurrence of any additional event, the value becomes incremented by 1 for that particular event. Now, as we have discussed earlier, whenever the value of vector clocks are updated after the execution of internal events, the arrows here will represent the dependency of one event with another event, and considering this causality or dependence, the values are sent between the set of processes P1, P2 and P3. So we can conclude that whenever there is the need of causality ordering between the events, then we are considering the vector clocks, and it will send the entire vector for the depending event, and it will help in making or keeping the clock in synchronization. For this particular vector clocks, I have used this link as a reference. Thank you all.